Hello students, this is the lesson 6 of chapter motion class 9 physics. In our previous lessons, we have learnt various terms related to motion such as what is distance and displacement, what do we mean by speed and velocity, types of motion as uniform and non-uniform motion, what is acceleration. Now in this lesson, we will study graphical representation of motion. Why it is needed? Because all the terms which we have learnt in previous lessons can be represented with the help of graph. So students, graph is basically a commonly employed tool which describes the motion of an object. That is, we can say that it gives the pictorial representation of the motion with the help of which we can determine the distance traveled by the object in a particular time period. We can determine the displacement in a given time interval. We can determine the velocity of the object at particular instant of time, how the velocity is changing, what will be the acceleration. All these terms can be calculated with the help of graph of a motion. That's why we need to understand graphical representation of motion. So students, in graph, what we do, we basically relate two physical quantities. For example, when you relate a physical quantity distance with time, then that type of graph is called distance time graph. And when we relate a physical quantity like velocity with time, then that type of graph is called velocity time graph. In class 9th, we have to study basically these two types. First, distance time graph, and second, velocity time graph. So distance time graph is such an graph which relates the distance with time or show the variation of distance with time. And second, velocity time graph is such graph which shows the variation of velocity with time. As in this class, we are discussing about motion of an object along a straight line in a given direction only, then in this case we consider the distance time graph as displacement time graph. Why? Because we know that when an object is traveling along a straight line in a given direction, then the magnitude of distance and displacement both are equal, and if distance and displacement are equal, then speed and velocity can also be equal. That's why speed time graph sometimes also referred as velocity time graph. Okay. Now let us start with distance time graph. So students, in this graph we study the variation of distance with time. It means distance is dependent on time. So we can say that distance is the dependent variable which is changing, and time is the independent variable, because time is not dependent on distance. Distance is dependent on time. So the dependent variable is always represented along y-axis, and independent variable, which is time here, is represented along x-axis. So for drawing distance time graph, we plot time t along x-axis and distance s along y-axis. So we have to consider following cases in distance time graph. Our first case is, what will be the nature of distance time graph for an object at rest? Now students, you know that an object is said to be at rest if the position of the object remains fixed and does not changes with time. So let us suppose that an object is situated at a distance of 8 meter from the chosen reference point, as we can represent it in graph. That you can see this O represents the reference point, and the object is situated at a distance of 8 meter, which is represented by A. So at t is equals to 0 second, it is at a position A, and after some time at t is equals to 2 second, it is again at the same position of 8 meter, and after 4 second means at 6 second, it is again at the same position of 8 meter. So joining all these points, we get a straight line which is parallel to the time axis. So we can say that distance time graph is a straight line parallel to time axis for an object at rest. Okay, now we will study the second case, distance time graph of an object in uniform motion along a straight line. Now students, you know what is uniform motion. An object is said to be in uniform motion if it covers equal distance in equal interval of time. As we have taken the situation here, let us see is this an example of uniform motion or not. So it is given in tabular form. This is the time t in seconds is represented, and this row represents the distance covered by object in meters. So we see that at 0 second the object has covered no distance. After 20 seconds the object has covered 10 meter. It means from 0 to 20, that is in 20 seconds the object has covered 10 minus 0, that is 10 meter. Again from 20 to 40 seconds, that is in 40 minus 20 seconds the object has covered a distance of 20 minus 10, that is 10 meter. And from 40 to 60, that is in 20 seconds, he again covers a distance of 30 minus 20, that is 10 meter. So we see that the object is covering an equal distance of 10 meter every 20 seconds. So we can say that the object is in uniform motion. Now plotting all these points, distance corresponding to time, in the graph we have the following nature of graph, which is represented as a straight line at an angle to time axis. So we can say that distance time graph is a straight line which is inclined at a constant angle from the time axis. So this is the case for uniform motion along a straight line. We can determine speed of object from the distance time graph. For this purpose, let us consider 2 points A and B on the graph. Let the point A corresponds to time t1 and distance s1, and the point B corresponds to time t2 and distance s2. Now what we do, we draw a line parallel to x-axis from the point A and a line parallel to y-axis from the point B. These two lines intersect at the point C. So we get an adjoining triangle ABC. In this triangle ABC, we see that AC represents the time interval t2 minus t1 and BC represents the distance s2 minus s1. So we can say that when the object moves from the point A to point B, it covers a distance of s2 minus s1 in time interval t2 minus t1. So we can write uniform speed is equals to distance travelled upon time taken, and distance travelled is equals to s2 minus s1 in the time interval t2 minus t1. So it is equals to BC upon AC, because s2 minus s1 is equals to BC and t2 minus t1 is equals to AC. Now the term BC upon AC is known as slope of distance time graph. That's why we can say that slope of distance time graph gives the speed of a moving object. Next is distance time graph of an object in non-uniform motion. Now students, you know non-uniform motion is that motion in which an object covers unequal distance in equal intervals of time. The following table shows the distance covered by boy R and boy S in equal interval of time along a straight line. From this data, we have the following graph of distance time for the boy R, and this is for the boy S. By seeing the graph for the boy R, you observe that the graph is not a straight line, but it is a curved line. And also you see that the distance covered by boy R in successive interval of 5 seconds is continuously increasing. That is, we can say that speed of boy R is continuously increasing. While when you see the distance time graph for the boy S, you observe that again the graph is not a straight line, it is a curved line, and in this case The distance covered by boy S is continuously goes on decreasing in successive interval of 5 seconds. So we can say that the speed of boy S is continuously decreasing. As both the graphs are for non-uniform motion, so by seeing the nature, we conclude that the distance time graph of an object in non-uniform motion is not a straight line, but it is a curved line. Velocity time graph. Velocity time graph tells the variation of velocity with respect to time. And for a motion along a straight line in a given direction, we know the magnitude of speed is equals to magnitude of velocity. So, velocity time graph is also known as speed time graph. Again, in velocity time graph, velocity is dependent on time. So, velocity is represented along y-axis and time is represented along x-axis. Let us study the velocity time graph for a uniform motion. For a uniform motion of an object along a straight line in a given direction, we know that the speed of the object is constant and also the object is moving in a given direction, so direction is also not changing. It means that the velocity of the object is constant at every instant of time for uniform motion. Hence, the velocity time graph for uniform motion can be represented as a straight line parallel to time axis. What does the area under the velocity time graph gives? To determine this, let us consider 2 points A and B on the graph. Let point A corresponds to time t1 and point B corresponds to time t2. Then we draw normal from the point A to the time axis, which cuts the time axis at the point D, and normal from the point B cuts the time axis at the point C. Consequently, we have a rectangle ABCD. In the rectangle ABCD, it is clear that AD is equals to V and CD is equals to T2 minus T1. Now, area of rectangle ABCD can be written as AD into CD. And we know that AD is equals to V and CD is equals to T2 minus T1. So, we have V into T2 minus T1. Now, we know that velocity into time gives us the magnitude of displacement. Hence, area of rectangle ABCD is equals to what? Displacement. So, we conclude that for uniform motion along a straight line, the magnitude of displacement or the distance covered by an object is given by area under the velocity time graph. Velocity time graph for uniformly accelerated motion when object is initially at rest. Now students, you know uniformly accelerated motion. Uniformly accelerated motion is that motion in which the object's velocity changes at a uniform rate, or you can say at a constant rate. It is clear from this table that the object is initially at rest because the velocity of the object at 0 second is 0. So we can say the object is at rest. And from 0 to 1 second, that is in 1 second, the velocity changes by 5 minus 0, that is 5 meter per second. Again from 1 to 2 second, that is in 1 second, the velocity changes by 10 minus 5, that is 5 meter per second. From 2 to 3 second, that is 1 second, the velocity changes by 15 minus 10, that is again 5 meter per second. So it is clear that the object is initially at rest and its velocity changes by a constant rate of 5 meter per second. Hence we can say that the object is uniformly accelerated. By plotting this data, that is at time t is equals to 0 second, the object is at rest. At time t is equals to 1 second, the object has a velocity of 5 meter per second. At time t is equals to 2 second, the object has velocity of 10 meter per second. At time t is equals to 3 second, the object has velocity of 15 meter per second, and so on. By joining all these points, we get a straight line passing through origin. So we can say that the velocity time graph for such an accelerated motion is an inclined straight line passing through origin. What does the slope of velocity time graph gives? For this, we consider 2 points, point A and point B, on the graph. Let the point A corresponds to time t1 and velocity v1, and point B corresponds to time t2 and velocity v2. Now we draw a line parallel to x-axis from the point A and a line parallel to y-axis from the point B. These two lines cut at the point G. Consequently, we have a triangle ABG. In the triangle ABG, BG is equals to V2 minus V1, that is change in velocity, and AG is equals to T2 minus T1, that is change in time. Now we know that acceleration is equals to change in velocity upon change in time. So we can say it is equals to V2 minus V1 upon T2 minus T1. And we know that V2 minus V1 is equals to BG and T2 minus T1 is equals to AG. So we can write it is equals to BG upon AG. Now the term BG upon AG is known as slope of the velocity time graph. Hence we conclude that for a uniformly accelerated motion, the slope of velocity time graph gives the value of uniform acceleration of a moving object. Velocity time graph for uniformly accelerated motion when the object is initially not at rest. From the following table, it is clear that at t is equals to 0 second, the object has a certain velocity of 5 meter per second. It means that the object is not initially at rest. Now, from this table, it is also clear that from 0 to 1 second, that is in 1 second, velocity changes by 10 minus 5, that is 5 meter per second. From 1 to 2 second, the velocity changes by 15 minus 10, that is 5 meter per second. And again from 2 to 3 second, that is in 1 second, velocity changes by 20 minus 15, that is 5 meter per second. So we can say that the body is uniformly accelerated, but initially it has certain velocity of 5 meter per second. By plotting the above data, we have the following graph, which shows that the velocity time graph is a straight line inclined to the time axis, but this time the straight line does not pass through the origin. Velocity time graph for uniformly retarded motion. Now students, there are two terms, one is uniformly accelerated motion and another is uniformly retarded motion. Uniformly accelerated motion means velocity is increased by equal amount, while uniformly retarded motion means velocity is decreased by equal amounts. So from this table it is clear that initially at time t is equals to 0 second, the object has a velocity of 30 meter per second, and after 1 second the object's velocity becomes 25 meter per second. It means in 1 second velocity is changed by 25 minus 30, that is minus 5 meter per second. Again from 1 to 2 second, velocity changes by 20 minus 25, that is minus 5 meter per second. So we see that every second velocity is decreased by 5 meter per second. Why I am saying decreased? Because we see that velocity is changed by minus 5 meter per second, and minus sign represents that the velocity is decreasing. So from this data we have the following graph, which shows the line sloping downwards. So this line sloping downwards represents that the velocity is going on decreasing. Velocity time graph for non-uniformly accelerated motion. Non-uniformly accelerated motion is such an accelerated motion in which the velocity is not changing at a constant rate, or we can say the velocity of a moving object does not rise or fall uniformly with time. So their graph will look like this. As you see in this graph, from the point O to A, the object shows the uniformly accelerated motion. But from point A to B, the object shows the uniform motion. Again from point B to C, the object shows uniformly retarded motion. Again from C to D, object shows uniformly accelerated motion. It means there is no fixed pattern. In the same way, in this graph you can see from the point A to B, the object is showing the uniformly accelerated motion, which is not initially at rest. And from B to C, the object is showing uniformly retarded motion. So these types of graph shows that object is in non-uniformly accelerated motion. Thank you students. In our next lesson we will solve some problems based on the graph and also study the three questions of motions. Thank you.